This is the ACES battery station. This battery station takes a standard rechargeable NiMH battery, and when you put it in to the battery slot, we'll charge the battery until it has reached a full charge. Part of this project is the MAX 712 CPE. It is a smart battery charger made specifically for NiMH batteries, like the AA rechargeable ones I use in this project. Instead of just dumping voltage into the battery, it actually monitors what the battery is doing while it is charging, which makes it charge a lot safer and fast. So, what is shunt regulations? One important thing about this charger is that it controls current, not voltage. NiMH batteries don't have a strict voltage limit, so you can't just regulate voltage. If you try to do that, you can easily overcharge or overheat them. By controlling the current instead, the charger can safely push energy into the battery and watch how it reacts. As the battery charges, its voltage slowly rises, but when it reaches full charge, the voltage actually stops increasing and slightly drops. The MAX 712 watches for that change. It's called a negative voltage slope to know when the battery is full. To see this happening in real time, I used an Arduino Nano to serial print voltage readings, which helped a lot for debugging. This graph shows how the battery voltage increases while the charge current stays mostly consistent. Once the battery is almost full, the voltage behavior change, which tells the charger to stop fast charging. This matched what I saw on the serial monitor and with the LED indicators. Now, RSense. The charger measures current using a sense resistor called RSense. It is a really small value resistor that lets MAX 712 measure how much current is flowing into the battery. One thing I learned here is that the battery negative terminal isn't actually at ground during charging because of the resistor. There's also a temperature sensor, which is a 10K thermistor placed near the battery. If the battery starts heating up too quickly, the charger can detect that and stop charging. This is a big safety feature and something real chargers use. Now, the power transistor and diode. The MAX 712 doesn't push all that charging current by itself. Instead, it controls a power transistor that actually supplies the current to the battery. There's also a diode in the circuit to make sure current only flows in the correct direction and nothing gets damaged. Now the LCD display. I didn't get this fully working on my printed circuit board, but you can see it pretty clearly here on my breadboard. And to make the system easy to use, this display shows battery voltage, charge percentage, and charging status. I also added 3 LEDs, red for low or no battery, yellow for charging, and green for a full battery, so you can understand what is happening from far. This breadboard prototype of the project is more accurately depicting on how the battery charges and how the LCD screen displays those values. Thank you very much for watching.